So this is your first lesson in Unit 3. So we're going to be talking in Unit 3 about expressions and equations. We're going to get started first with talking about some properties that we have that we're going to be able to use that kind of help us moving forward. We've kind of seen some of these properties already this school year, but we're going to just kind of refresh them and make sure that you are good with them. So we're going to start in your notes packet on page 2, and it's lesson 3.1, properties of numbers and one-step equations. So the first one we're going to talk about is the commutative property. And the commutative property, really simply put, just means that order can change. And this property only works for addition and multiplication. So you can't change the order in a subtraction or a division problem for obvious reasons. So this can be useful when you're working with negatives. So if you have an expression that has a whole bunch of positive numbers and negative numbers, you could actually reorder your addition and put all the negatives together and then put all the positives together, and then you just have to deal with one problem where you have to deal with who's actually got more, what is your sign going to be. So my first example I'm going to do here with you is going to be -3 plus 10 plus a -2. And what I would suggest doing here would be to add the -3 plus the -2 plus the 10. So why this makes it easier is you can add those together, -5 plus 10, and then you're just going to get a 5 for your final answer. So that's why the commutative property would be useful here. The other thing, when you're multiplying two numbers or three numbers here, we can actually just do it with 2 as well. 5 times 11 times 2, it might actually be easier for me to do 5 times 2 times 11, because 5 times 2 would get me 10 times 11, and multiplying by 10 is drastically easier than saying, oh, let me do 55 times 2. So the next one that we have is associative, and associative means that the grouping can change. So when we talk about grouping in math class, we're talking about parentheses, we're talking about brackets, something along those lines. Again, this only works for addition and multiplication. And again, can be useful when working with negatives. So useful with negatives. So, for example, if I had 40 plus 20 plus 10, what I can do is I can regroup these and I can do 40 plus, instead in parentheses, I'll put the 20 plus 10. So I'm allowed to actually move those parentheses around. For example, I can also do, if I had 10 plus a -6 plus a -4, I could swap around my parentheses and do 10 plus -6 plus -4. Why would that be super useful? Well, -6 and -4 would give me -10, and then I just have a 0 as my final answer. Final example, we're going to put in parentheses 5 times 11 times 2, and I'm going to swap those around, and I'm going to do it as 5 times 11 times 2 in parentheses instead. Two more properties that we're going to talk about today. The first one is identity, and identity does not change the original number. So whatever you start with or whatever expression you start with, the identity property is not going to change it. So when we're talking about addition, what can you add to a number so that it doesn't change what your number would actually be? If you said to go ahead and add 0, you are correct. So for addition, our identity property looks like adding 0. Now, that could be as simple as going 3 plus 0 equals 3, or -2 plus 0 equals -2. But it could also be something like if you had 5 plus a -2 plus a 2, because this is actually a 0, so this still represents the identity property. Thinking about multiplication, what can you multiply by so that it doesn't change your number? If you said multiply by 1, that would be correct. So we are going to show an example here of 3 times 1, which would leave us at 3. And if we had -3 times 1, that's still going to leave us at -3. Final example we're going to talk about today is called inverse property, and the inverse is going to be useful to us today as we start to talk about solving equations because the inverse property undoes something. So when we talk about addition, and again this works for addition here, we are going to add the opposite to make 0. So if I have a negative number, I'm going to add that same number just as a positive version. Or if I have a positive version, I'm going to subtract that number or add the negative of it to make it 0. In multiplication here, we are going to multiply by the reciprocal. And multiplying by the reciprocal will actually help us to make 1. So addition examples, if we have 4 plus a negative 4, it's going to give us 0. Or if we had like negative 1/2 and we added 1/2, that's going to give us 0. For the multiplication, 3, we're going to multiply by the reciprocal, which is going to be 1/3, and that's going to give us 1. If I had the fraction negative 3/4, I could multiply by negative 4/3. And yes, if it's a negative here, your inverse is still going to be a negative as well because you want to make 1. We want to actually make a positive 1, and the only way to do that is to do a negative times a negative then. Okay, flipping on over to page number 3, we're going to do a couple practice problems. So I'll do the first 2, and then I'm going to kind of have you answer some of these as well. So in example number 1, I have 9 times negative 2, and what I'm going to do is fill in negative 2 here, and I flipped-flopped these around, so we're going to call that the commutative property of multiplication, because I changed the order of my multiplication. Example number 2, I'm multiplying, and I have 4 times a negative 7 times a 6, and then 4 times negative 7 times 6. So it looks like my parentheses went from being here to now being around the 7 and the 6, which means my grouping changed. So we call that the associative property, and this is of multiplication. Take a look at example number 3, and you are going to type out what you think the property is as well as what operation it involves. So for this one, the order changed. This is commutative property, but this time we're doing addition. Take a minute, do a look at number 4, and you're going to go ahead and type in again what the property is and what operation. So this one, again, changed the associative property, and again, we're multiplying here. For number 5, we're going to talk about, we start with a 7, we end with a 7, and we're multiplying. So this must be the identity property of multiplication here. Example number 6, you might need to flip back for this one. We take something, we multiply it by 1/13, and we end up with 1. So what property allows us to end up with 1, and what are we going to fill in here? So the property that allows us to end up with 1 is the inverse property, and we used multiplication here. So it meant that we multiplied by our reciprocal, which is going to be 13. In number 7, looking at my numbers, I have 10 blank 4, 10, 6, 4, so it looks like the 6 needs to go there, and it looks like my parentheses changed, so we're going to call that associative property, and it's of multiplication. In example number 8, I end with 1 again, so this is another example of inverse property, so I'm going to multiply by the reciprocal here, which the reciprocal of 4 is 1/4. Take a look at example number 9. Look at your numbers, 10, 3, 5, 10, 3. What's missing and what changed from one side of the equal sign to the other? So for this one, we're missing the 5, and this is the associative property of multiplication here. In number 10, we have 4 plus 6 equals blank plus 4. It looks like I'm going to put the 6 there, and it looks like we actually want an answer. That's going to give us 10. All I did was change the order. So we call that the commutative property, and we were using addition. Last part for today's notes is solving one-step equations, and this is where we're going to use that inverse property. So our notes for solving, our main goal is to always isolate the variable. So what does that mean? Isolate means get it by itself, and variable means the letter. So what I like to think when I do this one, letters are loners. They like to be alone. So your job is to try and get that letter all by itself. So we're going to go ahead, isolate the variable. We are going to use inverse operations to undo what's there. And whatever we do to one side, we have to do to both sides of the equal sign. So what I'm going to have you do, these are super easy, and I get it that you're going to fight me on showing work, but I want you to start practicing now so you can see how I'm going to be asking you to set these up. First thing first, drop a line down your equal sign. I see x plus 12. X is what I'm trying to isolate. So I am trying to get this x all by itself right now. There is some other stuff over here, this plus 12. So what's the opposite of a plus? It's a minus. So I'm going to do minus 12. I'm going to stack them right up on top of each other here. If I do it to one side of this line, I have to do it on the other side. So I'm going to put a minus 12 over here, and then I'm going to ask you to draw a big old line, kind of like you would do underneath any other addition and subtraction problem you stack. The plus 12 and the minus 12, they're inverse. They give us 0, and all we're left with over here is x. Bring down your equal sign, and 15 minus 12 is 3. For here, we're going to drop our line down. Find that variable. Here he is. What else is over there? Well, there's a plus 5, so I need to do the opposite, which is a minus 5. On both sides, though, whatever you do to one side, you got to do to the other. All you're left with is r, and 32 minus 5 is 27. Take a look at this one. If we drop our line down here, I have 2 symbols here. So I know in the past we didn't want to use subtraction, but when we talked about integers, but here in order to figure out what operations we need, we only want one symbol in between here. So how am I going to rewrite this x plus negative 4? So if you're rewriting plus a negative, that really just means x minus 4. So you're undoing those 2 changes that you made before. Here's my x. That's what I'm trying to isolate right now. And over with that x is a minus 4, so I need to do a plus 4. Do it to both sides. X equals 15. Again here, I'm going to ask you to rewrite this one because I see double symbols, and then solve it. So rewriting, I'm going to write this as x plus 3 equals a negative 10. My x is my variable. That's what I'm trying to isolate. So I have a plus 3, so I need to do a minus 3. I'm going to get x equals. Over here, just think about these as adding. A negative 10 and a negative 3, that'll give me a negative 13. For this next one, we're going to rewrite this as x plus 4 equals negative 2. And there's my x, so I'm going to minus 4 on both sides. X equals negative 2, and a negative 4 is a negative 6. Last example that we have here, we have multiplication attaching a number to our x, which is what I'm trying to isolate here. So how do I undo multiplication? Division. But if I divide by 5/9, because that's what's stuck here, I'm actually going to end up multiplying by the reciprocal. And this is actually that whole inverse operation still with multiplication. Remember, inverse property says we can multiply by the reciprocal. That gives us 1x, which is really what we need, and x equals, I only did it to one side. Holy smokes. So we have to multiply both sides times 9/5. Quick trick if you're not sure how to do this one, 20 divided by 5 is 4, and 4 times 9 is 36. Or you could write it over, and then you could reduce. This would be a 4, this would be a 1, and 4 times 9 is 36. So that wraps up lesson 3.1 that you have for today. So that is your first lesson in your Unit 3 notes packet, and it is all about properties of numbers and one-step equations.